odd. Not really caring that much at this point. Okay. So we have our greatest integer function. Here is what it looks like, kind of rearranged. So we're going to list first the horizontal reflection. And then first period, there was a good question asked about which axis that is over. So remember, vertical reflection means going from up to down, and horizontal means going from left to right. So this means you're actually going to flip over the y-axis, because that would change something from facing right to facing left. Okay? Then the second thing we'll do is we'll shift to the right 2. And notice that the translation is 2 because we've factored out the 3. Okay? And it's to the right because it's kind of the opposite of what we see here. And then what is this 3 going to do that's inside of the brackets? Horizontal compression. Okay? And so what's going to happen is normally in our step function, how long are our steps in our parent graph? 1 unit. How long are they going to be now that there's a 3 multiplying inside there? A third of a unit. Okay? So this is going to be a horizontal compression. And I'm just going to remind myself for later on when I'm graphing it that that basically means all those horizontal lengths are going to cut down to kind of a third of what they were before. Then I have the vertical, the stuff that's happening outside of the brackets. So with the 2 here, I have a vertical stretch. And that means those vertical distance will get multiplied by 2. And then I have a minus 2, so that means we're going to go down 2. Okay. All right, so I'm just going to start with 2 steps so that when I reflect them and change the distances between them, I can see that in my graph. So that's normally what the 2 steps would look like for our parent function. Now, on the test, it's going to ask you guys for specific information when you're going through these graphs. And you're going to have to graph all 6 of them, okay? Some sort of transformations with each one. Not surprising because we've studied 6 of them and we have transformations. So what I'm going to ask you for is I'm going to ask you for the graph. So you're going to be expected to get that. I'm going to ask you to list the transformations. I'm going to ask you for domain and range. And I'm going to ask you to list the vertex point. It just helps me when grading them check that you're in the right area of your graph and you understood the transformations. And what I mean by the vertex point is that point on your parent function that started at 0, 0. Where did that point end up? Okay? So any idea where that point's going to end up based on the fact that reflections and stretches and compressions don't really change that point? Only shifting changes that point. So where do you expect our vertex to be in this if it's at 0, 0 currently based on our shifting? Say it again. 2, 2. So I expect it to kind of end up at 2, 2. Does that make sense? Okay? Just based on the shifting. Because remember, the stretching and compressing, everything either moves away from the vertex or closer to the vertex, but the vertex doesn't move. Okay? And since we're reflecting first, our vertex isn't going to move before we reflect it. So it's only going to get moved during the shifts. And so that's where I expect it to be when I'm done. Okay? So you can list that at the beginning and kind of know that's where you expect to go, or you can do all your shifting and everything like that and list it at the end as part of your answer. But just so you're clear on the expectation when you list that. All right, so the first thing we're going to do is we're going to reflect it. So when we reflect horizontally, we're reflecting over the y-axis, which means if the line appeared to be like facing to the right, like here's the closed endpoint, it goes to the right and then opens, it's actually going to stay, the vertex is going to stay there, but the step is going to shift this direction, okay? And then normally this one started here, it's going to start here, it's going to go this direction, just like you fold it over on the y-axis and you can see it on the other side. All right, then the next transformation we're going to do is we can go ahead and then shift and finish up all of our horizontal stuff. So if we shift everything to the right 2, then these steps are going to end up over here. Okay. And then we're going to go ahead and we're going to do our compression. So remember what you guys said that meant. That meant that the step used to be 1 unit long, and now it's getting compressed by a third, so it's going to be a third of a unit long. Okay? So what I'm going to do is I'm going to start with the one that was my vertex point. So remember that this step here had the vertex point attached to it, right, that I've shifted over to the right. That's the step I want to change the length of, and then I'll adjust everything else after that according to the pattern that the step function should follow. So I'm going to go ahead, I'm going to erase it so I can put one that's a third of a unit long on there. I can fit it. So mine looks closer to a half because it's really hard to draw a third of a unit long up here. But it's supposed to be a third of a unit long, which means the next step should start where that one ended and then go another third of a unit. And the next one would start where that one ends, and it would go another third of the unit. Okay? So the steps follow the same pattern. One starts where the other one ends horizontally. Okay? But we changed how long they were, so that kind of crammed all the steps together, which makes sense because we were doing a horizontal compression. So it makes sense that your whole graph is going like this, horizontally. All right, then we're going to vertically stretch it by 2 and shift it down 2. So this means instead of the steps being 1 unit apart vertically like they are here, that vertical distance is going to get changed by a factor of 2. So 1 times 2 is going to be 2, so every step is going to be 2 units apart. I'm not going to change my step with my vertex point on it. Okay? I'm only going to change the ones that came after that. So 2, here we go, and then 2 more. Okay. So there's my steps with the vertical stretch, and then I'm just going to move everything down 2 for my final graph. So this step is not going to start here. It's going to start here. And then the other steps are going to follow the pattern that the step graph follow with the order of the points that I have here and 2 steps apart vertically. Okay. And you guys don't have to put more than 3 steps on your graph either. You just have to be able to name the proper domain and range. And did the vertex point end up where we thought it would end up? Okay. So this was kind of like my main step right here. So the vertex point ended up at 2, -2. And that was what we thought based on the shifting that could occur. Okay. Does that make sense? And then I did see on some of the transforming graphs, like you guys had a step function to do, and some people did V's or they did lines or something like that. So make sure that you guys learn the shapes of those parent graphs as we go through them, so that that's not the reason why you miss the problem. Okay. All right, so the next ones we're going to look at are on the quadratics. We're going to look at number 5 and number 6. So you can find your handout on quadratics. It said parabolic functions on it, and then number 5 and number 6. What you guys are going to do with these handouts, again, is you're getting stamps on your stamp sheet for this unit, but at the end of the semester, you're going to have an entire collection for every type of graph that we've studied, and you're going to turn it in as like a graphing portfolio with like a reflection written on it. So the extra thing you're going to have to do for this project, so to speak, is just put the reflection in as long as you've kept up with the work along the way. It says parabolic functions at the top. It's for quadratics, all the parabola-shaped ones. So I'm going to go ahead and fill in the stuff that you guys should already have. So we didn't go through and correct all of these, but part of the reason we didn't do that is because, again, you guys are going to get like a project credit for this, which is like a test grade once you've accumulated all of them throughout the semester, plus written a reflection. So it's your job to kind of stay on top of them throughout. But then these 5 should certainly be right because we're going to have gone through them. And again, the 2 in here is going to give us a horizontal compression. So it's always like you're using the reciprocal of the stuff that's multiplying when it's a horizontal change, but you're using the exact same number when it's a vertical change. So our parent functions for our parabolas, they have 0, 0. Then 1 unit away, they're 1 unit up, and 2 units away, 4 units up for our parent function. Okay? So that's what our parabola normally looks like. We fill in those points. What's going to happen when we do a horizontal reflection with this graph? If we did a vertical reflection, it would go downwards. Nothing. It's going to appear that nothing happened, right? Because the point on the right that was at 1, 1 is going to end up at -1, 1, but there was already a point at -1, 1 that will now end up at 1, 1. Do you see how that horizontal change is not going to affect that graph? Okay? Because if you fold the parabola over the x-axis or the y-axis, you already have it sitting on top of itself. Okay? So that's actually not going to do anything to our graph. Then we're going to move it right 2. And if you're like, that doesn't make sense, algebraically it does make sense because what's happening to this -2 is it's going to end up getting squared And when you square a positive, it ends up positive. When you square a negative, it ends up positive. So you can see why they wouldn't make a difference. All right. Hopefully the ceiling doesn't come kicking in. All right, so we're going to then shift it right 2 and horizontally compress it by a half. So I'm going to take all these points and shift them right 2. So my vertex is going to be at 2, 0, and then it's going to have the same kind of points surrounding it, 1 over and 1 up in each direction, and 2 over and 4 up in each direction. And I'll erase the points that no longer need to be there. Okay, and then our last transformation is to horizontally compress by 1/2. So somebody tell me what I'm going to do with my points in order to make that transformation on my graph, because I feel like these are the things that people are struggling with the most. Half the distance, which direction? Good. Okay, so half the distance left and right this way. He's exactly right. And I like that he went from both directions inward because we're going to go towards the vertex. That's what's going to happen. So this point is not going to change. Okay? So what we are going to change is how far everything is from that horizontally by this compression of 1/2. So none of the heights of the points are going to change. These 2 points are going to stay at a height of 1. Okay? It's just where they're occurring horizontally that's going to change. And because it's a compression, we expect them to occur closer to the vertex rather than further away. So normally the distance between the vertex and this point here is 1 unit. Because it's getting compressed by 1/2, that distance is basically getting multiplied by 1/2. And 1 times a half is going to end up being a half. So I want this distance to not be 1. Instead, I want it to be a half. In other words, this point's going to be here, and same on the other side. Okay. And then for the point that's up 4, that point that's 4 units above normally is 2 units away from the vertex horizontally. Again, I want to adjust that by the expression by multiplying by a half. And 2 times a half is going to give me 1. So I don't want this point at this height to be 2 units away from the vertex. I want it to scoot closer to the vertex and only be 1 unit away. So only 1 unit away from the vertex is this height of 4 going to happen, and same thing in the other direction. So that our actual parabola after all the transformations is the skinnier one in here. And you should be able to look at it and see that it makes sense. Does it look like you took your graph from the horizontal ends and compressed it closer towards the vertex? Okay? That it got skinnier like that. It should match what you're saying in the transformation. Okay. All right, any questions about that quadratic? No? Okay, so there's one other one on the quadratic handout. So right below it, or next to it, number 6. So again, you should have already have all of this work done. Okay, another thing on your quizzes that I noticed is when you factored out the 1/2. Okay? So you had a similar problem on the quizzes. It had a 1/2 x plus 1 or a 1/2 x minus 1, something. Okay? Some people just looked at it and said, oh, 1 is the shift. And they said right, left. I got multiple answers each direction. Okay? But 1 is not the shift. Okay? What is actually going to be the number there of spaces that we're shifting? 2. Okay? Because it's not the one that was there. It's the number that should be there after we factor out 1/2. So 1/2 times what would equal 1 is what we're trying to figure out. All right, so I'm going to write what I think you guys already have on there. And make sure that you guys have this listed as a horizontal stretch because of the 1/2. And whoever is making the noise, can you please stop so other people can concentrate even if you don't have any reason to concentrate? It's like my freshman class. All right. We have a vertical reflection, and we have a shift down 3. Okay, so first check that you have all of the transformations correct. We already talked about, since it's a parabola, is the horizontal reflection going to affect the shape of our graph or the location? No. Okay, because the parabola is already going to be split right at the y-axis. Then we're going to shift it right 2. So the vertex is going to move here. And we'd have those same parabola points. So 1 over, 1 up, and 2 over, 4 up. Okay? If you're wondering how I get those, you either need to think about x squared. When you plug in 2, you get 4, stuff like that, or memorize your parent functions. Okay? So then we're going to go ahead and stretch it horizontally times 2. So the same thing we talked about before, but you guys just compressed the last graph. Now you need to stretch it. Can you guys please stop so that we can finish this, whatever the problem is? Okay. So last time we compressed. This time we're stretching. Okay? So these points that were 1 unit away from the vertex, we're now multiplying it by 2. So we want that point to take place 2 units away from the vertex. So the vertex is going to stay where it is. Okay. Right now, this point at a height of 1 is going to stay at a height of 1, but rather than being 1 unit away, we want it to be 2 units away, so it's going to be over 2 and up 1, okay, and over 2 the other direction and up 1. And in that same respect, okay, these points right here, they used to be 2 units over from the vertex, but we're multiplying that by 2. So I still want to plot that point, but I don't want it to be 2 units away. I want it to be 2 times 2, which is going to be 4 units away. So it's going to be at 4, 4. And 4 the other direction away from the vertex and up 4. So right now we have this kind of wider looking parabola. And that makes sense because the change we just did was to take it horizontally and stretch it. So it makes sense that it would go from this outward like that. Okay? All right, then we want to vertically reflect it. So what we want to do now is we want to take all those points. We want to flip them over the x-axis. Notice that the vertex point is not going to move because it's on the x-axis. So it's still going to be in the same place, but everything that was above the axis will now be below the axis. So all of these points will now just get plotted below the vertex. Okay? Same distances, but downward instead of upward. So there's how it looks after our vertical reflection. And the last thing we want to do is we want to move everything down 3. Okay? So take your whole graph and just shift everything down 3 units. Okay? So then you'll have your final function. All right? Is that okay? Yes? No? Questions? All right. And then what would the domain be for your function? Because you guys are going to have to name it on the test. All real numbers, because left and right, there's no restraints. What would be the range for your function? Close. But y is less than or equal to -3 because the whole graph is below. Okay? And did the vertex end up where you thought that it would end up? So our vertex point is here, which is 2, -3. Does that make sense with the shifting in the problem? Did you move 2 to the right and 3 down? Okay? So 2 to the right and 3 down. So all that stuff should kind of connect together, little things you could do at the end to kind of check if you feel like your graph is right. Okay? All right, the next one and second to last one that we're going to do is from the cubic function. So look for your cubic function. And again, you guys should already have this all done. And the only thing that might change a little bit is your graph. So we have our horizontal reflection. We have a shift right 2 again. And then we have this vertical compression. All right, where do you think the vertex for this graph should end up if we do all of our transformations correctly? 2, 0 is where it should end up, okay? So a shift 2 to the right, no shift up or down, okay? So 2, 0. So if you remember for the cubic, and a lot of you guys are mixing up the shape of the cubic and the cube root, okay? Does this grow fast or grow slow? Sorry, if you take things and you cube them, it grows really fast, right? So these are the ones that are shooting up and down, okay? Because by the time you get to 3, you're cubing 3 and it's already equaling 27, okay? You cube 4 and it equals 64. So they're shooting up and down, okay? So you have these points at 0, 0, 1, 1, and -1, -1, and you got to make sure that it curves around and shoots up and down very steeply at the edges, okay? So that's the parent function for the cubic. So then what's going to happen if we do a horizontal reflection with this graph? Huh? Good. Yeah. So the vertex stays, and what was on the right becomes on the left, and what was on the left becomes on the right. So this point's here, and now our graph would go in this direction. So people were talking about how when you horizontally reflect this graph, it actually looks the same as if you vertically reflected it because of the nature of the graph, which is true. Then we want to go ahead and move everything right too. So the vertex would then be here, and we still have those points, one away and one up and one away and one down. Okay, so it's just the whole thing's been shifted over to the right too. And then we want to go ahead and we want to vertically compress. So that means we're only going to change the vertical distance of the points. So looking at what we have so far as what's going to be our final graph, this blue curve here. Okay? If we want to vertically compress the points, what we want to do is keep our vertex in the same place. And we want to change how high or how low, how far away vertically the points were that we were graphing around it. So they were one above on this side, one below on the other side. But now that's getting compressed and is getting multiplied by 1/2. So instead of a distance of 1 vertically, I want it to stay in the same place horizontally. I'm not moving it right or left, but I want it to only be a distance of 1/2 from the vertex. So it's going to go like this. And same thing for the one that was below it. Okay? So that's going to cause the curve of your graph to stretch out just a little bit more. Okay? Because it kind of took it and went like this. Huh? Well, yes, so there's two. So this one's a horizontal one, so it's moving things from left to right. And if there was one out here, then it would flip it up and down. Yeah. And some of you ask me, well, if you have one type of reflection and then you have the other, don't they just undo each other? Well, it just depends on the function, right? This one, yeah, flipping it left and right looks the same as flipping it up and down. So if you flip it left and right and then you flip it up and down, it's just going to look like it's back to the original curve. But think about the quadratic that we just did. Flipping it left and right really did nothing, but flipping it downward did a whole different transformation, right? So just do them separately still. Don't make assumptions about them because depending on the way the function behaves, it will turn out different each way. Okay? All right, and then we can see our vertex ended up where we thought at 2, 0. Okay? It's right here. Okay? All right, and the last one we have to look at is a cube root function. So number 7 in there. And so hopefully, besides just fixing this for us, this gave you guys some sort of review with the functions. Most people got pretty good at them, but then, like I said, when I was looking at your quizzes, we were struggling a little bit with parts of it. So, all right, so first thing, when I factor out the 1/2, what value should be left in this set of parentheses right here? So 1/2 times what would give you 2? 4. Okay? So that's going to be important to our shifting and things like that we end up in the right place. So somebody tell me, where do you think our vertex of this graph is going to end up? 4, 3, okay? Because there's a shift of 4 to the right and 3 up. So that kind of is just like a self-checking for me. One, I am going to ask you to list the new vertex on the test so you can find it that way or through all the transformations. But that's also going to help me match what I see in the equation. Does my graph match at the end? And if not, maybe I didn't do something correctly. So we have our horizontal reflection. We have our shift to the right 4. And remember, having a 1/2 here, is that a horizontal stretch or compression? Stretch, okay? The inside stuff is all wacky, right? Remember? So, like, this says -4, but it's really a shift to the right 4. This says 1/2, but it's really taking stuff horizontally and stretching it times 2. Okay? So we have a horizontal stretch times 2. And then we have the shift that's going to go up 3. All right, so cube root has the same 3 main points as cubic. Their names are similar. They both have that little teeny 3 in there. And they have the same main 3 points, which is why people are getting them mixed up. But when you were taking something and cubing it, you were getting it really big, really fast, which is why we shot up, right? But here, when you take the cube root, like, what number would you have to take the cube root of to get 2? 8. Okay? So you'd have to be all the way out at 8 before you'd even get to 2. What number would you have to take the cube root of to get 3 as your answer? 27. So you'd have to be all the way out at 27 before you'd get to 3. So the cube root function grows really slow. Okay? So that's what the parent function looks like. So first thing, horizontal reflection. And it is built a lot like the cubic, so kind of the same thing. We reflect horizontally, which kind of looks the same as if we reflected vertically. Then we're going to move everything to the right 4. So 1, 2, 3, 4. So we have our graph in that position. So we reflected it, and then we shifted it to the right 4. So now we're going to do the horizontal stretch by 2. So someone tell me, like, where should I have a new point to put on my graph? Is the vertex going to change? At the end, after we stretch. Good. The distance between your vertex point and the next point you plotted is going to change horizontally. Up or? Good. So instead of being 1 away, I want it to be 2 away because 1 times 2 is 2, so that point's going to end up there. And then the same thing here, right? And make sure it makes sense. So the new graph's going to look like this. Okay? And that kind of looks like we took it horizontally and stretched it out a little bit. And then the last thing we have to do is just move everything up 3. So there's my new vertex point. There was the point above and the point below when we were finished with the transformations. So then I have this function here. Okay. And you guys said the vertex point would end up at 4, 3. So if I'm kind of checking my work before I move on to the next problem, I can see my vertex point appears to be at 4, 3, so I feel like I did it right. Seems to be facing the right direction with the reflection. Things seem to be in the right place. It looks like I horizontally stretched it. So everything seems to match with kind of what I thought about the function. Okay? Any questions about this? No? Okay. All right, so we fixed